Okay, for this next set of directions, it says solve for the indicated values in number 14 through 17. So what you need to do here is use the previous idea that every single one of these pictures has a different number of sides, and so the interior angle sum is going to change for each of those. So the first thing that we're going to do is we're going to calculate the interior angle sum. So there are, let me change colors, let's see. There are, counting sides, I have 1, 2, 3, 4, 5, 6 sides total. So how do I find my interior angle sum? That's going to be 6 minus 2 times 180 degrees. When I do that, I have an interior angle sum of 720 degrees. So all of these should add up to 720. Okay, so I'm just going to make a note of that. All of these inside angles should have a total sum of 720 degrees. So what we're going to do is we're just going to add them all up to 720. You could just take them and subtract every single one of these you have on here in pink, and that will leave you with what's left for n. That's essentially what we're going to be doing when we set up the equation. So n plus 156 plus 122 plus 143 plus 108 plus 110, all of those should have a total sum of 720 degrees. So whenever you combine like terms, you end up getting n plus 639 when we put all of those numbers together equals 720. And you'd subtract 639 from both sides, and what you would be left with is 81 degrees for n. 81 degrees. Okay. Exact same thing on this next one, except for instead of a 6-sided figure, I have a 1, 2, 3, 4-sided figure. So many of you know that the interior angle sum of a quadrilateral is going to be 360, but in case you didn't know that, we could calculate it by doing 4 minus 2 times 180. That's going to give me 360 degrees for that interior angle sum. Okay. The only problem is, as of right now, if I were to set up an equation, there would be an x and a y. X plus 112 plus y plus 88, adding up to 360 would not help me very much since there's two different variables. So what I need to do is I need to solve for one of the other variables first. So the first thing I notice is that x is adjacent and making a linear pair with 110. So if together those add up to 180, how much is left for just x? X is going to be equal to 70. If I know that x is 70, that's going to help me because now I can set up my equation and only have one variable. So I know that all of these should add up to 360, so I could just subtract off all of these three numbers and see what's left for y, but I'm going to set up the equation for the people that need it. So 70 plus 112 plus 88 plus y, all of those should add up to 360. I combine my like terms and I get that y plus 270 is going to be equal to 360 degrees. And so I'm going to subtract 270 from both sides, and I end up getting that y is equal to 90. So y is equal to 90, and then x is equal to 70. All right, number 16, also an irregular polygon, just like all of the others so far. So let me count the number of sides. Let's see how many sides we have. It looks like a pentagon, but let's count it and check. 1, 2, 3, 4, 5 sides. So we're going to do 5 minus 2 times 180 degrees. 5 minus 2 times 180 is going to give me a sum of 540. So what should all of these add up to total? 540 degrees. So this is one where we can't just subtract everything that's there. We're actually going to have to write our equation. Okay, so it's going to be all of these added up together, make a total of 540. You could do this by just putting the x's together, realizing I could go ahead and combine like terms, all of those x's, and then putting together all of the other values as well, or constants. But I'm just going to write it out for you. So we have 5x plus 5 at the top, 4x minus 10, plus 4x plus 15, plus another 4x plus 15, plus 4x minus 10. All of those should have a total sum of 540 degrees. So again, I'm going to go put all my like terms together, 5x and 4x and 4x and 4x and 4x. All of those are going to have a total sum of 21x. Let's put together my like terms. That is going to be 5 minus 10 plus 15 plus 15 minus 10. All of those are going to have a total, combined total of 15 when I combine those like terms. And that is going to be equal to 540. I don't know what is happening to my pen. I might have to restart my iPad before the next video. I don't know if it was dropped or what, but it looks like my Apple Pen is a little bit struggling here. You can see how I'm writing. It's only picking up part of it. So I'm going to subtract 15 from both sides. I get 21x is equal to 525 when I subtract that. And I divide by 21 on both sides, and I get that x is 25. So if it actually asks you to go back and find the angles, we would just plug that in for each of those the angles expressions, and it would give me the angle. Okay. Regular heptagon, it already tells me that there's 7 sides, but we could count it if we needed to. If it didn't, 1, 2, 3, 4, 5, 6, 7. This is an exterior angle, so we don't need to know the interior angle sum. We need to know the exterior angle sum. Well, the exterior angle sum is always 360. And since it tells me that this is regular, I can just divide 360 by 7. What is 360 divided by 7? 360 divided by 7 is going to be about 51.4 degrees. So this is an exterior angle, and that exterior angle is about 51.4. I don't know if it's exact. Let's see, 360 divided by 7. Yeah, 51.4, so that is rounded. So we rounded that to the nearest tenth because that's the directions that I added. All right, this next set says to list the 5 properties of parallelograms. So here's what I'm going to do. I've already written it all out just because it takes a little while and I didn't want to waste video time writing it, but I'm going to mark it in the picture. So list the 5 properties of a parallelogram and mark the picture accordingly. So I'm going to color code this. I want to color code this in a way that for 18A, I want to mark the opposite sides parallel. So remember we do that with those little arrows, those little triangles. That shows that the opposite sides are parallel. We also want to mark both opposite pairs of opposite sides congruent, so both. So I'm going to do that with a pen. That's going to be these two are congruent, and then this set is congruent as well. So both pairs of opposite sides are congruent. You know what? I'm going to fix that a little bit. One second. Let me move this over. I'm going to use a pen for all of this because I just think it'll make it easier to read. Okay. So in yellow, we marked our parallel sides. Those are parallel. Those are parallel. Both sets. In green, I'm going to mark the congruent sides. Those are parallel, or those are congruent, and then those are congruent. Then I want to mark both pairs of opposite angles congruent. So I'm going to do that in blue. Opposite angles are going to be congruent to each other. So this angle is going to be congruent to this one. And then this angle is going to be congruent to this one. I'll mark those differently to show that opposite angles are congruent. And then we want to mark the consecutive angles as supplementary. So on that one, I'm just going to kind of put a star on it. I'm going to say, hey, these add up to 180. All of the ones that I have arrows to, we're going to add up to 180. So the ones that are next to each other, those have a sum of 180 degrees. These have a sum of 180. So if they're next to each other, consecutive means that they're next to each other. So like consecutive letters of the alphabet would be like A and B. Consecutive months would be like February and March. So they're next to each other instead of opposite each other. And then we are also told that the diagonals are going to bisect each other. So I'm going to do that in purple. The diagonals in this shape, we need to draw them in. Those diagonals, I'm going to draw in from here to here. Give me a straight line. There we go. Oh, that's not straight. From here to here, that's much better. That one to that one, and this one to this one. Those are my 2 diagonals, and those diagonals cut each other in half. So I'm going to show this part is congruent to this part. There's the midpoint. And then 1, 2, 3, 4, that part of the diagonal is going to be congruent to this part of the diagonal. Okay, so those diagonals bisect each other. And that is every single property of a parallelogram in that picture. We want to do the exact same thing, but we want to list the 2 special properties of a rectangle and then mark the picture accordingly. So it says, what are the 2 special properties of a rectangle? Well, there are 2 things that are important in a rectangle. Number 1, part A, is that there are 4 right angles. So let's do that. In a rectangle, there need to be 4 right angles in that parallelogram. Okay. The other thing that we know is that the diagonals are going to be congruent to each other. So this diagonal is going to be the exact same length as this diagonal. So maybe let's put some letters on this, A, B, C, D. We would know that the diagonals A to C is going to be congruent to B to D. Those are congruent. We also can add, we know that because this is a parallelogram, it says include the parallelogram properties. I'm just going to add the additional ones. I'm just going to add what's new. Okay. So what I'm going to do is say, okay, because I know that those diagonals are congruent and because I know that it's a parallelogram, I know that these pieces, all 4 of these pieces are going to be the same length. because if the full amounts are congruent, the 4 individual pieces are congruent as well. So that's what the extra properties for a rectangle. So I'm only going to mark the extra properties just to save us a little bit of time. Okay, list the 3 special properties of a rhombus and then mark the picture accordingly. So what we're going to do is we're going to mark that there are 4 congruent sides. So let's do that in color first. There are 4 congruent sides. That is the definition of a rhombus. So 1, 2, 3, 4. All 4 of those are going to be congruent, so I'll mark them all the same. We also know that the diagonals are going to be perpendicular to each other. So when I go and draw in these diagonals, they should cross each other at a 90-degree angle. So this one, those are different lengths. They're going to cross each other in a way that they create 4 right angles. So the diagonals are perpendicular to each other. And then we also know that those diagonals bisect the opposite angles. So all 4 of these green angles that I'm putting in are going to be congruent. Those angles get bisected. Those opposite angles get bisected. All 4 of those amounts will be the same. And then all 4 of these star amounts will be the same around this diagonal. So in this pink diagonal, there we go. In the pink diagonal, we are also creating congruent angles because those diagonals are bisecting those opposite angles. So that is going to be our new information. That's our new information in a rhombus. And of course, in the rhombus, we have 4 congruent right triangles that pop up. So if you are looking how to solve a problem later, these do have 4 congruent of these purple right triangles in them. There are 4 of those that are the exact same. Whereas in the rectangle picture, I didn't want to go back and explain this. In the rectangle picture, remember that these are isosceles triangles. The purple one and the purple one are going to be the ones that are congruent. Those are isosceles triangles, not right triangles. And then this pinkish reddish one is going to be congruent. This isosceles triangle is going to be congruent to this pinkish reddish one. So top and bottom and then left and right. Okay. Whereas on this one, all 4 of these are going to be, could be colored purple because they'd be the exact same triangle.